What's up, Sum Hacker? Welcome to my Summer Day Challenge, where I unpack a banger practice sum every single day to help you crush your grade 11 maths. Let's dive in and work on today's math sum together. So this type of question can get some students super messed up because what ends up happening here is you actually have two unknowns, not just one, two. And that can be a little bit freaky if you don't know what to do. So just so that you know, the kind of question that you will get, it will say something like this, okay? Determine the values of A and B for which the following will always be true. I think this is something you need to just make sure you take special note of, okay? So then what we've been given here is a little nasty, but once you know what to do, then it becomes super easy. And if you practice these a couple of times, it's going to become like second nature for you. Let's get stuck in. If you haven't yet, pause the video, write down the sum, and if you're ready, let's dive in. Okay, so the first thing that I want to do first, let me take that arrow away. I actually want to change this 8 to its factors, and that is going to be to the power of 3. Okay, so that's the first thing I'm going to do. Because essentially, what I'm going to try and reconcile here is I want to try and make this side and this side as similar as I possibly can because they are both equal. So if they kind of look similar to me, then I can figure out what these unknowns are. Okay, so your next step looks like this. You have your cube root. And remember, I'm changing the 8, so it's going to be 2 to the power of 3 x a is equal to b x over 3. So obviously a quick one. I didn't mention it, but the two unknowns that you're trying to solve for here, a and b. Okay, just so that you're clear before we move on here. Right, so the next thing I actually want to do is I want to take this cube root away, okay? And how I can do that is I can put this entire thing under this cube root in a bracket, okay? That would be to the power of 1. And then what I'm going to do is I'm going to stick this 3 underneath to make a fraction like that, and then I can take the root away. So let's go ahead and do that now. So we're going to have bracket 2 to the 3 x to the 9, right? To the power of a third. Awesome. I've got that cube root away. Now that's equal to b x 2 over 3. All right. So the next thing that I want to do is multiply my third into the bracket with these other exponents. Okay. So here's what we're going to get. 2 to the power of 3 times a third and x a times a third. And that's going to be equal to b x 2 over 3. All right, so now I'm going to simplify these, okay? So that is going to give me 2 to the power of 1 x to the power of 1 over 3a, okay? Equals to b x 2 over 3. Okay, so now you should be seeing that both of these sides are starting to look pretty similar. Okay, so as you can see here, we have a variable and a variable. Then we have an x, then we have an x, and then we've got our exponent, okay? So we actually have done the hard work of trying to get the side looking similar. So now what we want to try and do is solve for one of the unknowns. And the easiest one that is going to be to solve first is going to be this 2 and the b. Because the question said that these sides are exactly equal, okay? They are it will always be true that they are equal. Can you see that b is actually equal to 2, okay? So you can actually write that down. B is equal to 2, okay? And that would be 100% correct at this point. Now we're going to substitute our b back into this equation. So we're going to say 2 to the x to the power of a third a is equal to, remember b we are substituting with 2, and then we've got our x 2 over 3. Now, because we have the same bases here, I can divide both sides by 2. So let me do that now quickly. Because essentially what I want to do is get x alone, and then I want to try and get a. Okay, so that's essentially what I'm busy trying to do here. So my answer will now be x to the third a is equal to x 2 over 3. All right, now again, can you see we have the same bases? We have an x here and an x here, which means we can drop the bases and work with the exponents. So your next line is going to look like this. Third a is equal to 2 over 3. All right, so now hopefully you're starting to see, okay, it's coming together, right? So I want to get a alone, and the way that I do that is I try to take away whatever is in front of the a, okay? This is separated by an invisible multiplication, so I can divide, but if this was separated by anything other than a multiplication, you would not be able to do this. So if there was a plus in between those variables or a minus, you would not be able to do this, but it's separated by a multiplication, and so we can divide. So this is going to be divided by a third, 1 over 3. Okay, so if you're not super sure how to do these fractions, I'm going to do them real small, real quick on the side here. Okay, so you're going to have a third divided by a third. Whenever we divide fractions, we need to change the sign and flip the back end of this fraction. So it's going to be a third times 3 over 1, and then you multiply horizontally. So that's going to give you 1 times 3 is 3, and 3 times 1 is 3, and that will give you 1. Okay, so we actually have 1a here. We don't need to put the 1, we can just put a. Then what we want to do is the exact same thing for the other side. So what that's going to look like is 2 over 3 divided by 1 over 3. Okay, we change the sign and flip the reciprocal or the back half of that fraction. So it's 2 over 3 times 3 over 1. And we multiply horizontally. So 2 times 3 is going to give us 6. 3 times 1 is going to give us 3. And that simplified is going to give us 2. Okay, so can you see here that we've got 2? So our final answer here is a is equal to 2. And that would be 100% correct. So your very final answer here is a is equal to 2 and b is equal to 2. There it is. Now you have worked out 2 separate unknowns correctly, and you will never need to worry about getting this wrong ever again. Well, friggin' done, Sam Hacker. That is it for today. And if you reached the end of this video, please let me know if you found today's sum helpful in the comments below. Plus, be sure to subscribe for more daily practice sums that are going to help you nail your grade 11 maths. And let's keep building into your future one sum at a time. I can't wait to see you here in the next one.